What's up, guys? We are entering Unit 7. We are going to apply triangle sum properties in this video today. So there are two ways that you can classify the type of triangle, one being by their side lengths and the other being by their angle measurements. Now, we're not necessarily going to be given exact numbers that represent the length of a side or exact numbers to represent the exact measurement for the angle, but using tick marks will be a good indicator of how you can tell if sides are congruent or if they are not congruent, or same thing with angles. So with the first triangle here, if we have three sides that are not congruent at all, and the diagram's kind of small, there are no tick marks that represents congruency. So if that occurs and we have no congruent sides, we call that triangle a scalene triangle. Now if you notice a second triangle, we have two tick marks here. 1, 2. We call that an isosceles triangle. So the two sides that have the one tick mark means that they're both congruent, same measurement. So if they only have two measurements that are, or two sides that are the same, we call that isosceles. The third triangle, if 1, 2, and 3 have the same amount of tick marks, or there's two here in this case, there are three congruent sides, which means it is an equilateral triangle. So that's how we classify our triangles, by just the side length. That's very important to know. Now, to classify the triangles using the angle measurements, well, the first one, if we're looking for acute angles, and you notice that there are 1, 2, 3 angles that are acute. And again, acute is less than 90 degrees, a measurement that's less than 90 degrees. And if there's 3 of them, we call this an acute triangle. Okay? So in the diagram, it looks like we have 3 congruent angles because these are called angle marks right here. So we don't necessarily know that they're all the same measurement, so we're going to add 1 here and add, let's say, 3 here, just to indicate that there are 3 different measurements. So the second triangle, if you notice that we have a little box in one of the corners, okay, that is considered a right angle. So a right angle's measurement's 90 degrees. So if you notice that a triangle has a 90-degree angle, or a 90-degree angle in it, we call that a right triangle. Okay? And then, the next triangle over, if we have one angle that has a bigger angle, we call that an obtuse angle. There's just one of them. So that measurement's got to be greater than 90, but less than 180. And if there's one obtuse angle, we call that simply an obtuse triangle. And then finally, if you notice that all of the angles, 1, 2, and 3, have the same angle marks, that indicates that those angles are congruent. So if you have 3 angles that are congruent, then we call that an equiangular triangle. Okay, so there you go. Those are the 2 ways that you can classify triangles, by the side lengths and by the angle measurements. Alright, the triangle sum theorem states that the sum of the measures of the interior angles, so the angles that are inside of the triangle, interior, the sum of those measures of those angles will equal 180 degrees. All the time. If it's a triangle, all the angles inside will add up to 180 degrees. So we have angle A, the measurement of angle A, plus the measurement of angle B, plus the measurement of angle C, will give you 180 degrees. Okay, the next theorem or property of a triangle is the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 interior angles. So highlighted in green, we have our exterior angle, and our exterior angles form when you take one of the sides of the triangle and you extend it past one of the vertices. And that angle right here is called our exterior angle. So this measurement is equal to the sum of the 2 interior angles opposite from it. So in example 1, it says find the measurement of angle DCB. Well, before even actually finding the measurement of angle DCB, we have to find an exact variable that represents, or that's represented in the problem. Okay? So there's our exterior angle. So we have 3x minus 9 equal to 73 plus x, our two opposite interior angles. So then we have a equation, or an equation, with variables on both sides. So we're going to first subtract our x from both sides. Simplify, 2x minus 9 equals 73. And then since we have our variable term on one side of the equation, get our constants on the other side. We're going to add 9 to both sides. So then 2x equals 82. And finally divide by 2, and we get 41. Now many of us would stop there and call it a day, but the question's asking for the measurement of angle DCB, not what the value of x is. But we need x to figure out what the angle measurement is. So we're going to take our angle DCB, which is 3x minus 9, and substitute in what we know. We know that the x is 41, so we're going to substitute in 41 in for our x, and simplify. Boom. I don't know why that went so quick, but 3 times 41 minus 9, we get 123 minus 9. And then going further, the measurement of angle DCB is 114 degrees. All right, these are the last two properties of our triangles that you have to be able to identify in order to solve a problem using the properties of triangles, or even when we actually get into proofs, apply as well. So the first one's called the base angles theorem. And the base angles theorem states that if two sides of a triangle are congruent, then the angles opposite of them are congruent as well. So if we have our two sides that are congruent, if you look closely, the angle opposite of side AC is angle B. The angle opposite of AB is angle C. So if these two sides are congruent, A and B, then angle B should also be congruent to angle C. And going backwards, we know that if the two base angles are congruent, angle B and angle C, then we can conclude that AB is congruent to AC, so the sides opposite of those congruent angles. In example 2, it says triangle FGH. FH is congruent to GH. Name two congruent angles. So here's our triangle right here, and we know that FH is congruent to GH. Well, since those two angles are congruent, well, the angles opposite of those sides that are congruent, FH is angle G, the opposite of it, and then GH, the opposite angle is F. Those two angles will also be the same measurement to each other. Okay? So we can say triangle FGH is an isosceles triangle because we have the two sides that are congruent. So then we can say angle F is congruent to angle G. All right, and the second property works with equilateral triangles. It says if a triangle is equilateral, and going off of the base angles theorem, since all the sides are congruent in an equilateral triangle, then the angles opposite of those congruent sides will always be congruent. So we can say that if the triangle is equiangular, then it is also considered equilateral. Wow, I can't even read that. It originally said equilateral, so then we can say it's equiangular, All right, and vice versa. If the triangle is equiangular, then we know that it is equilateral. So it works back and forth. If they just give you that the angle measurements are congruent, you can conclude that the sides are congruent as well. Or vice versa, if they give you the sides that are congruent, all three of them, then you can conclude that all of the angles will be the same measurement. So in example 3, find the measures of angle R, angle S, and angle T. Well, if you look at the triangle here, all sides RS, ST, and TR all have 3 meters, or all measure to 3 meters. So we can declare that triangle RST is equilateral. That's what we can conclude. We notice that the 3 sides are congruent, so then all the angles are congruent as well. And if you can remember, what do all the angles add up to in a triangle? The interior angles. Anybody? Good. 180 degrees. Since all the measurements of the angles are 180 degrees, well, since they're all the same, since all the angles add up to 180 degrees, and they're all the same, if we divide that by 3, we get the measurement of each angle. So then angle R is congruent to angle S, which is congruent to angle T, which all equal 60 degrees. Alright guys, thank you for watching. Miss DeLulo was not here to record the video, but she misses you guys very much. Hopefully you guys can read the handwriting because that's all hers. Alright.